Good morning, ladies and gentlemen of calculus.
Good morning, Mr. G.
Thank you. What we're going to be doing today is, have we looked at the chain rule before?
Yes.
Yes, we have, right? So we're really recycling around after we've picked up. Now, the main thing we look at here are these two things right here, 2 and 3, and especially 3. But this thing is not really, the graphics are not very good. Here, this thing, it doesn't, you have a hard time picking it up. What this says is f prime. So if you have the derivative of a composition of functions, that's going to be f prime of g of x times g prime of x. So it's going to be the derivative of this function here times the derivative of the inside, which is what this is really telling you too, except using the power rule where you have a power here. So I find that this thing right here, this second thing, is really helpful when you have a table or something like that, where you just have to think through. So if you refer back to that, I like it personally. It's going to be easier when you can use this method 3 of doing it. So let's go through some problems in this, and these are going to be reviewed. So right here, are you going to use this second method or the third method on this problem one? Yeah, the third method. And so your f prime of x is going to be what? It's going to be f prime of this. Well, how do you find the derivative of this if you treat this as a single thing? 3 times the inside, right? Plus 7 to the power of
3x, or 2.
to the power of 2 times the derivative of the inside, which is going to be 3x squared. And the last thing is just if you can combine what the factors are here. So you're going to have like 9x squared times quantity x cubed plus 7. Now, could and squared, could you have expanded this out and done these and took the derivative of these terms individually? Yes, you could have. But was that going to be a much longer process than using the chain rule? Yes, it is. So that's going to be number 1. Any questions on that? It's good to see Hannah expelling that carbon dioxide. All right, good. No, it's important. If you don't expel carbon dioxide, you can't survive.
Exactly.
And the plants would die.
Yeah.
Oh, that's true too. Yeah, you're part of the
And then when
biosphere.
the plants die, y'all wouldn't have oxygen, which would make y'all die, so you're welcome.
Hannah just saved our lives.
I get it.
Mr. G, that's all I have to do in pilot's license on Sunday?
Did you finish it?
Mm-hmm.
Oh, really good. Well, that's a real accomplishment. How many hours of flight did you have to log to be able to do that?
I have around like 50 right now.
Okay.
Like the minimum is 40, but I had to like do this like over like a year and a half, so it was
Yeah,
hard to
right.
do more.
Well, that's really an accomplishment. Okay, with 2, we're down to the trigonometric one. Do you remember what the derivative of cosecant is? I think I remember what it is. What's going to be the derivative of cosecant? Because that's a little side problem. Anybody remember what that is?
Check the other notes.
You can check the notes, right? Well, let me give you a little hint before you check the notes. I'm going to give you a little hint of that. And it's probably, okay, the ddx of cosecant, remember I told you to put down like negative, the thing is you put negative cotangent, cosecant, cosecant. Okay, so this is the thing you put up there, and you cross off whatever you're taking the derivative of. What are you taking the derivative of here? What are you taking the derivative of here?
Cosecant.
Cosecant. So it's like you cross this off, and whatever's left is what you have. So the derivative of this is going to be negative cotangent x cosecant x. So that's the derivative of this. So let's go ahead and apply that to this problem here. F prime of x is going to be, well, we're going to have 1/5, right? And then what's the derivative of this thing here? Well, it's going to be negative cotangent what? 3x. And cosecant 3x. And times what?
23.
Times 3, times the derivative inside. So our final answer is going to be this right here. We got negative 3/5 cotangent 3x cosecant 3x. Now I will tell you from my experience of teaching over the years, this is the 10th year I've been teaching calculus. Thank you for helping me get to year 10.
Hey.
But what happens is, some people like to change this for some reason. They like to say, okay, well, the derivative of this, they forget and they just put x. But that inside thing always stays the same. Right, so you're always going to have that. And so this is going to be your f prime of x. Okay? Questions on that one? Again, this is a memory device where you put cotangent, cosecant, cosecant as far as taking the derivative. And do you remember what it is for tangent and secant?
And secant.
It's tan, secant, secant. And so if you have these in your memory bank here, or write them down when you're taking a test like that, these are some quick guides to help you get problems there. Okay, let's go to next sample problem here. Take the derivative. I want you to go ahead and take a minute taking the derivative of this. You should be able to do that. So just take a minute on that, and then I'll work it out here in about 2 minutes.
That was hard.
That one's hard. You see while you work on that, I'm going to take a look at what the others are.
I had.
Okay.
Well, let's see.
Yeah, we're going to be working on these tomorrow a little more. All right. I don't know how far you are along in this, but I want to show you here. I would treat this as a product of two functions. So we talked when the product where we talked about u and v, didn't we? So here we have in v, I'll put this aside, v is equal to 2x minus 3 to the 1/2 power. Does that make sense? So v prime is going to be, what is v prime going to be?
Oh, wow. 1/2.
1/2.
2x.
Okay, we have 2x minus 3 to the negative 1/2.
2.
And times 2, is that what you said, Aaron?
Yes.
Times 2. So these are going to cancel out. So we have here is we're going to have 1 over square root of 2x minus 3. So that's going to be v prime. And so now when we set up our little product rule box like this that we've been doing for how many months now have we been doing this?
6.
Maybe 6 or a lot. So here we're going to put x, what is our derivative of x? 1, thank you. And here we have square root of 2x minus 3, and then we have over here 1 over square root of 2x minus 3. And so now what is going to be g prime of x? X over square root of 2x minus 3 plus square root of 2x minus 3.
Oh, that actually wasn't that complicated.
No, it's not. And here's the thing about it is what the College Board does when they have a problem like this on the test, because you'll see ones like this, what they do is they combine them as a single thing, and they actually factor out this thing right here and get something that looks different than this. So in case you should run across something like that, so you'll have this thing factored out 1 over anyway. It looks different. It looks different even though it's the same thing. So next thing we have here is this thing right here. I want you to do this one, number 4. And we'll go over it. This one here I think is a little simpler than number 3. Okay, this case too, I'm thinking that we have a product of 2 functions, so just treat these as a product of 2 functions, and we put our little graphic organizer up here like this. Is this how you did this one?
Yes.
I hope you did, yes. Okay. So here we have x squared, and what goes over here? X squared, 2x, and here we have sine 2x, and what's going to go over here?
Would that be 2 cosine 2x?
2 cosine 2x. Alright, so now we think y prime is going to be equal to this thing right here. So we get 2x squared cosine 2x plus 2x sine 2x. And if we wanted to, we could factor out, or common factor, I guess we could take 2x out of here. But that's really what it is. Okay, let's go to this one here. Find the equation of the line tangent. Point we're just running short on class time. And this is one of those that we could expand it out, but we don't have to do that. So we're given our point and our slope. Treat this as a product of 2 functions. So we have x. Our derivative of x is 1. And then we have this thing here, we have quantity 1 minus 2x cubed. And what's our derivative of this going to be? What's our derivative of what's going to be d dx of 1 minus 2x cubed? What's that going to be? Okay, rule 3, right? What's rule 3 say to do?
I'm trying to do it on my own.
Okay, we take this 3 out here. 1 minus 2x squared, and our derivative of the inside, -2. So we get -6 times 1 minus 2x squared. So we have f prime of x being -6x 1 minus 2x squared plus 1 minus 2x cubed. And if we plug in 1, we get f prime of 1 equals -6. And if that's going to be -1 squared plus -1 cubed. And so that's going to be what? 6, or -6 minus 1,
-7.
so -7, is that it? So what we're going to have is y plus 1 equals -7, x minus 1.
Yeah,
So that's it, you got that one? Good job.
Good.
See you tomorrow.